All right. So hi guys. I'm going to start. Um, I'm going to give this talk in English, so I get a chance to polish my English a bit. So I'm Yoav Aharoni from Pink Park, CTO at Pink Park. And in this talk, I want to share our story, the way we started with Docker, the lessons we learned on the way, and what we gained from it. So just to put things in context, a bit about Pink Park. Pink Park started as an application for sharing private parking spots, kind of like the Airbnb, but for parking spaces, right? And later on, as we grew, we started supporting a lot of type of parking spaces. So now we support big lots and private spots. Some have gates, some don't. And eventually, to deal with all the types of gate that we now have and spots, we ended up developing our own technology for opening the gate, which we call Gate Connect. So basically, we have our application and our own hardware that we put at the gate. And of course, we have all our backend, where we have a back office and our APIs, which is obviously where Docking comes into place. So that's about us. And basically, like I said, this is going to be a Docker talk, right? Just another Docker talk. When we're going to look, yeah. All right. Where we're going to talk about Docker. So, but the only difference is that you're going to listen, you're going to hear it from our side, the way we experience it. And so, if you already know Docker and you just realize that you're going to be bored for the next half an hour, now is a great time to leave. I won't be disappointed. I assure you. But if you want to start your own journey, I like we did, so I guess it's a good place to start. So why Docker? Why did Pink Park start Docker? So I'll be happy to tell you it's because all the fancy features that Docker have that we really needed, and we just needed to have them in production. But if I'm honest, and I am, the true story is that I just found it neat, right? I heard about it, I saw talks about it, and I thought it's something that I need to try for myself. So in our story, Docker just started as a side project, right? That I did for fun, after hours, because we are a very lean startup, right? We have no time for anything other than our business logic, right? So if you want to do something like that, we probably won't be approved to do it on working hours, all right? Some guys are joining. But the funny thing is that not having time, the reason for which we almost didn't have Docker, turns out to be exactly the reason why we do need Docker, because now that we have Docker, we can do all of these things that we otherwise just wouldn't do, because we wouldn't have the time for it. So it's turned out to be a valuable asset for us. All right, so we can have a talk about our story of Docker without first touching and talking about what Docker is. So for me, in one sentence, Docker is simply an ecosystem, a complete ecosystem to run containers, all right? And you can't talk about Docker without talking about containers and images. So basically, what is a container? A container is a very clever way to get your app, your package, whatever app you're having, basically any Linux application that you have, and to ship it and deploy it with all of its libs and dependency, even including the Linux distribution, all right? So suppose you have your Java WAR application, right? But instead of deploying only a WAR to your server, like we did not so long ago, you want to ship and deploy it not only the WAR, but also with the Tomcat, the Java, and everything that it needs in order to operate. And this is a very powerful tool, and why is that? Because if tomorrow I want to upgrade and start using Java 9 instead of Java 8, which I use now, I just ship the application and everything works. I don't have to go through the process of upgrading all my servers and all my Tomcats, etc., to make it work, right? So we talked a bit about containers, and what about images? So in an object-oriented world, images are like the definitions of a container, right? So you can think of image like a class, we defined what's going to be in your container. So in the Java application, so we have our application, and images, just like classes, they can inherit, right? So I can have an image of my application, which inherits from another image of Tomcat, which inherits from another image of Java, and onwards and onwards until you get to the base image of your Linux distribution. All right? And basically, images are like ogres, meaning that they have layers, right? So we saw that an image has layers because of its inheritance, but every tiny image by itself is composed of little bits of. All right, some other guys are coming in. Thanks for joining, guys. So every image itself is always composed of very small steps, where each of them adds another data to our layer. All right, so that's basically Docker in a couple of words, and now let's get back to our story. So I wanted to start with Docker, and we have our production environment, and we have our staging QA environment, and we have all of our servers doing the DevOps work, right? We have Jenkins, Artifactory, ELK, and so on and so on. So I want to start with it, but the question here, where do I start, right? So obviously, one does not simply walk with Docker into production, right? You first got to get your hands dirty to get the feel of it, right? So that's exactly what I did. I didn't start with production or the prod environment. I started with DevOps, because DevOps is my world. Pardon my language, if I fuck something up there, it's only my problem, right? Nobody above me will get upset about it. So that's exactly what I did. And being at the Jenkins conference, it's only fit that I start with Jenkins, right? So the first thing I did, as I said, all right, let's see how easy it is. Let's try to replace my current Jenkins container with a Jenkins instance that runs, my current Jenkins, which wasn't a container, with another Jenkins instance, which runs on a container. And that's exactly what I did. So what I want to do now is recreate this fabulous moment when I started with Docker. And the first thing I did, after installing Docker, of course, which is, by the way, very easy now when you have Docker for Mac and Docker for Windows, and I just searched the Docker repository for Jenkins. All right, and then I went ahead and grabbed the first line I saw, which shows me how to start Docker. And that's what I did. Basically, just ran it. And as you can see, just one line. And out of the box, without doing anything, I had Jenkins running. And wow, it was an awesome moment for me because I couldn't believe how easy it is, right? So much easier than Yum yet, I guess. Not really. But it was really, really easy. And I didn't. So I enjoyed it, and I started working with it. I started configuring my new Jenkins instance. But it wasn't too long until I realized that all the configurations I just did in Docker, they're going to vanish the next time I want to upgrade my Jenkins. Because the next time I want to upgrade Jenkins, I want to throw away my old container and put a new one up, right, with a new version. Containers are supposed to be disposable, right? So luckily, Docker gives us two ways to deal with it. The one is you can just mount any folder on your host, right, where you host your container. You can mount any folder of the host into a Docker container, so you can put your configuration there, and that would work. The folder on the host will obviously remain there, even if you tear down the container. And another option, which Docker calls volumes, is you can set up a volume. Now, volumes are actually volume containers. The storage is handled by Docker itself, all right? So they're basically stored around the same place where you store your images, etc. The only difference is that images are read-only, and these data volumes, they are, hey, Tomer, this is the brains behind Pink Park. You can say hi. So the difference being that this this volume are rewritable. So, and they are also persistent, and they are not part of your container. So if you replace your container and throw it away and put a new one, everything just works. And between the two options, for most of the times, you want to use a volume, all right, and not a folder, and there are two reasons for that. The first one is that it's more portable, right? If you use a folder and you want to take that container somewhere else, you gotta have the same folder on your other machine, all right? So you gotta make the same path and everything. And with volume, it will just work, all right? So that's the first reason. The second reason is that when you create a volume, every data that you already had in the folder on the container where it was mounted on is kept. I mean, suppose in our case, we have a Jenkins instance, right? And Jenkins, it already comes, when I bootstrap it, it comes bundled in with a bunch of configuration files. So if I use a volume, all the files that were there are kept there. But if I use a folder, it's just overridden, all right? So I need to in advance, put whatever configuration was there, all right? So that's the pros. There is one annoyance that comes along with it. You can't access directly volumes. You have to only access them through another container. So if you want to do something with it, you have to go into your container, do a bash, and do whatever you want with it. All right? So I had my Jenkins running, and I felt great about it. And then something happened. I had a YAM update, and my Jenkins fell down. And why was that? The answer is simple. I had nothing that kept my Jenkins running, right? Once it was down, I have no servers, no daemon to tell it to raise up again. So foolishly, when I noticed it the first time, I did whatever I was used to do before. I created an upstairs service that simply launched my Docker, which launched my Jenkins application at Bootstrap. But only a couple of containers later, I figured out that there's a much simpler way to do it. Docker provides you with a restart flag, all right? So when you start your container with Docker run, you can just provide a restart and state always restart this container if it stops, no matter what. You can do that. I mean, this option is what you call a stupid proof, right? No one can stop this container. If you want to prevent somebody else for stopping your container unintentionally, so this is the option for you. The other option is unless stopped, which will only restart the container unless you stopped it yourself, which is good if you have a smart team and you want to maintain and upgrade your Docker and do get it down from now and again. And the last one is on failure, which is probably not good for servers, but it's good for one-time script. It will only restart your container if it fails internally, right? Because of an exception or other error. All right, so that's great. The way I did with Jenkins, I did with my other service, and everything was great. And then I noticed another thing. I noticed other people are using Docker not just for server, but for scripts. So I thought I'd do the same thing. And basically how it works is that, all right, let me tell you first why we need it. So we obviously have lots of scripts for doing all kinds of DevOps work, right? For instance, we have an Nagios server, and if I want to update all the list of the servers in my Nagios, I do it with a script. So we have two kinds of script. One is a shell script, and the other one, for me, because I'm a JavaScript guy, I use Node script, right? And the problem is that there are two problems. One is not everybody has Linux, all right, or shell script, and the other, for instance, we have a guy that doesn't like Node, all right? So if I'm telling him, you gotta install Node to use my script, he's gonna get pissed off. And that's basically what happened before. But now with Docker, I can just create a shell script that launches a new Docker component, right? With Node or with whatever I need, and pass it along my script and run it. And I get two things. One thing is that everybody can now run my scripts, and they don't need to configure anything in the environment. And that's great because also every time I want to upgrade and start using a new Node or new Ruby or whatever, nobody needs to upgrade the environment to use it. And the second thing is that now I don't clutter my environment, my local folders with all the crap that for instance, Node. Whenever time I ran a Node script, so I get this Node modules folder, right, wherever the script was. So now I don't have it anymore. My folders are clean because all of the files are now in the container and not where the CPU, not in the local folder on the host where the script used to be. And another bonus is that you can now share versioned scripts with, suppose you have a Slack, and I want to share my script with it, but so I can just take a snippet of my Docker script which runs the script, and I can put it on Slack, and everybody that will run that piece of script will always get the latest update of my script because I can push in the repository my latest image of the script. So basically, all you need to do to run the scripts in Docker is you have this Docker run --rm, which all that it does is, all that it does is tell Docker to remove the container once you're done, all right? So Docker will just create a container, run your script, and tear it down and destroy it once you're done. All right, in this example, I'm running a Node script. So I'm mounting my scripts and run yarn install and my script. All right. So this was great, all great when I had just one server to put up. But then I came to my environment and I wanted to set up ELK, right? Which is a stack for us. We store our logs in it, right? And it's composed of Elasticsearch, of Logstash, and Kibana. All right, so I have a bunch of servers that I need to get up in order to use this stack. So for that, luckily for us, instead of having to run several commands, Docker also provides us with a Docker Compose. All right, and Docker Compose is basically a tool in which you can write one YAML file which describes all the servers that you need, and you just write one command. Docker Compose up in the folder where you have this YAML file, and all the servers will be up. So let's see this too. Now I can show you my ELK, but instead of that, I want to show you another sample app, which if we have the time, we will also use for swarming. All right, so let's just check that. I hope it's big enough. All right, so let's just look at this YAML file. So I have this Docker Compose file, right? Docker Compose YAML, and I have two services. I have the web service, which is my application, and in this demo, my application also depends on a Redis server. So I want to put them both up in order for the application to work. So all I need to do is to define the service. And you can see I have a web service. I define the image, all right? I have my app image, and I have another image with the Redis. I map the ports and everything. And you can see the nice thing about this Docker Compose file is that all the configurations are stored in the YAML, right? So you don't need to pass any other variables like we did with the Docker run, all right? Because with the Docker run, I had to specify every time I wanted to run a container, I had to specify the volumes I wanted to link, etc. And here it's already configured in. So let's see, run. And I'm going to do Docker Compose up. And now Docker is going to create this application for me. And I will have it running. Oh, sorry. All right, and this is my application. It just shows me my host and how many times I ran it before. All right? So that's great. So now I can, now with one command, I can set up several containers. And as a side effect for that, you saw before that when I'm using a YAML, the Docker Compose YAML, and not the Docker run in itself,
I don't have to specify any variables and everything. I just do Docker compose app. And the side effect of that is that everything is already documented. Everything I need to know in order to run that container is already documented in this YAML file. So what we ended up doing is, in the end, converting all of our scripts for running the server into a YAML file, and then everything now is just Docker compose app, right? So before we start with Docker, let's take this ELK server for example. We have these huge README files, all right? This huge README file with all the instructions of how to create it. I need to create the Elasticsearch and the log search and everything, and then it was reduced to a shell script which runs a couple of Jenkins. A couple of Dockers containers, and then it was reduced to a README file with just one line, Docker compose app and a compose YAML, which was great. As you can see, I was very excited about it, right? Because now I have no docs and no strips, and that's a great thing. So after I learned how to compose my own Docker file, and after I learned how to launch all the containers, and after I got my hand dirty and learned all the bits and pieces and tricks that you need to, because every ecosystem at the end have these bits and pieces that you need to learn to get, that you need to learn, excuse me, that you need to learn in order to get things done right, right? You made a few mistakes and you learned from it, you get on. In my case, it was, the couple of lessons I learned was, one, you should aggregate as many run commands as you can into one run command, because each of them, if you remember, each run command add a different layer to our image. So if, for instance, you create a big file in one run command, and in the next run command you delete it, you end up in the layer that you have in the image, you still get that file there. So your image is very bloated. But if you aggregate it to run one command, create it, and then delete it, so the committed image will be much smaller. Right, the second thing is that when you have a Java application, you always need to manually set your XMX, your heap space, because it turns out that Java, for instance, and a lot of other applications don't respect the memory bounds which you put on a container. All right, but it's a little technical explanation to explain why. But basically, it's because the Docker, it's not like a VM, right? You don't host your entire OS and run it in a complete sandbox. It's just a collection of tools which Linux supports to separate things. But if your application are not using, for instance, the code in Java, for instance, doesn't use the memory limits which is defined by Docker, then it will ignore it. All right. And another lesson is that you should probably always, when building your own images or when we are on Azure, you can use Alpine or another minimal distro. Basically, Alpine is a very minimal Linux distribution, and the benefits of it, one, your images are much, much smaller, which also improve your build times, and decrease your attack surface, right? Because if you have a Linux distribution with fewer libraries, there are also less ways to attack you. All right. So even before we went to production, what we got out of the Dockers. So now we have all our DevOps set up in a very maintainable way. I can upgrade and replace each server with just a few clicks of a button. And we're in scripting heaven, right? Now I can run any scripts. I don't have to worry about anybody else running into issue with the environment, with not having the right node version, or even having Linux installed. Everything just works for everybody. Everybody can run any script. And by moving into a concise methodology where every server we have is defined in a Docker compose, and we use the same methodology for everything, so it's really improved the way we communicate and document things, right? We don't need to document, we don't have this long README file because everything is described in a YAML file. So I finally was done with our DevOps environment, and I was finally ready to go ahead and tackle our production environment. And of course, you don't start with production, you start with the staging environment. And obviously, we use Jenkins to to build and deploy, and we have pipelines that runs all this process. So if you're gonna go to the Docker plugins website, you're gonna find a bunch of plugins that handles and does integrate in some way with Docker for you. But if you're using pipelines for us, I guess the only one that we need is the Docker pipeline plugin and a couple of shell scripts. So let's see this one in action too. All right. So I have this one also here. Sorry. All right, so I have this Jenkins pipeline, all right, and it's also just a Docker compose, which basically puts up a registry of Docker and a Jenkins instance, all right, so I can just use it with Docker compose up, -d, all right, and I just did it. So basically what you get when you do that is when you use this plugin, all right, let me enlarge it for you a bit. So what do you get when you work with the pipeline plugin? You get this Docker global environment variable, all right, where you can use to do all kinds of things. Like the first thing is to build your image, right? You have your own image application, and let's see an example. Let's see an example here, all right. So we have a pipeline here. So I have Docker with registry, which which I just use to define the registry I'm going to push and pull my images from, and I provide the credentials, and then you can get, all right, in this demo specifically, we use Docker for everything, right? So if you want to build our app, we don't need Maven install. We put up an image of Docker which has Java and Maven in it, and we build our application, all right, with its container, and then we tear it down. And then we take the app that we just built and put it in another container, all right? And then we take this container and launch another container to test it, all right? Integrate system tests, all right? And when all of that is done, it reports the results. So let's see this happen. So we have our Maven image, all right? So I do Docker image and create our Docker image. And then with it, Maven inside is just a command where you can run whatever you want inside the container which you just launched, all right? So here we're just doing Maven and building our repository, all right? Clean and package. And once we have it built, once we've built and we have our jars, we go ahead again and do a Docker build, all right, and build our app. App here is the parameter that we provide the build, which is the folder in the structure of our Git. We have an app folder which contains the app itself, all right, and then we push our image to the registry, and then we test it. So in order to test it, like I said, we have another image that we are going to build for the test, and then we run it, all right? And once we run it, inside it, we link it to our other container, do whatever we want with it, which is run the test in this case. And this test specifically, by the way, which I took from the Jenkins team themselves, so thanks for that. It also runs a screenshot. It also takes a screenshot of the application and lets you manually approve your app, right? Because it's a web app, so it takes a quick screenshot. So let's see it run. All right. So the first step, as you can see, I'm creating all right, so here I've created the Maven image, all right, and then I've built it, and it's all happening very fast. All right, and here you can see that I've run inside my container the Maven, all right, and everything just running perfectly well inside the container. And eventually, let's skip right to that. Here I have, excuse me. Wait a second. So there's supposed to be a pop-up here to viewing the screenshot. Don't know why my mouse stopped working. All right, I'm sorry for that, but just a problem. Just a problem with it. It worked fine before, but actually, what you're going to see a screenshot of the application, and you get a screen here when you can improve it manually, and then the image is promoted, and you can just use whatever configuration tool you use. Once the image is approved, it is pulled to your registry, and then you can just go and tell all your servers to pull the new image, and that's it, and do Docker Compose or whatever you have. So that's basically when you are now. And if you want to stay here for a couple of more minutes, our next step is to take it to the next level and to use Swarm. So right now we are doing it in our staging environment. And if you wanna go ahead, I'm gonna show that. Basically, we're about it at the end of our talk. So let's wrap this up before that. So at the end of the day, what did we get out of our experience with Docker, right? So the first thing we got is a proven production reliability, right? It works. It actually works, and it's stable, and everything works great. The second thing we got is that now our QA guy can test our branches locally very easily, right? It doesn't to have any development environment installed. He can just run it locally, or we can run it for him at any of our servers without any issue. And we just wouldn't do it if we didn't have Docker, because it would take too much time and too much effort on our side, right? The third thing we got is better automation, because like you saw, now we can run system tests and test against environments which are much closer to production using the real MySQL, which you didn't do before, again, simply because it didn't worth the time for us. And because everything is now well documented even the production is well documented in a YAML file, and all the development files, we have easier handoff. When a new guy comes along, there is much less that I need to explain to him in order to run scripts and etc. And all the previous perks we talked about before in DevOps. If you want to run these demos or other demos, you can grab this talk at Git. Thank you.